Welcome back to Module 2, Physics. In this video, we finish thermodynamics, covering the four-stroke engine cycle, thermal efficiency, and latent heat. A piston engine repeats a cycle of four strokes. First, intake, where the piston moves down and the intake valve opens to draw fuel and air in. Second, compression, where the piston moves back up with both valves closed, squeezing the mixture. Third, power, where ignition fires and drives the piston back down. And fourth, exhaust, where the piston moves up again and the exhaust valve opens to push the burnt gases out, ready for the cycle to begin again. Thermal efficiency tells us how much of the energy put into an engine actually becomes useful work. ETA equals W out over Q in times 100%. Some of the input energy always escapes as waste heat, so no real engine reaches 100% efficiency. Latent heat is the energy needed to change a substance from one state to another without changing its temperature. Q equals mL, where L is the specific latent heat of the substance. Here, ice absorbs energy and turns to water, but both stay at 0 degrees Celsius throughout the change. Plotting temperature against heat added gives a heating curve. The sloped sections show specific heat warming the substance up. The flat sections show latent heat, where energy is going into changing state instead of raising the temperature. Melting and boiling both show up as flat plateaus on this graph. Not all latent heat values are equal. For water, melting takes about 334 kilojoules per kilogram, but vaporizing takes about 2,260. Melting only loosens the bonds between molecules, while vaporizing breaks them apart completely, which takes far more energy. That is why a steam burn is so much worse than a burn from hot water at the same temperature. Here is one for you to try. Calculate the energy needed to melt 2.0 kilograms of ice. The specific latent heat of fusion is 334 kilojoules per kilogram. Pause the video now. Read the question and select your answer. The correct answer is C. Latent heat changes state, not temp. Read the question and select your answer. The correct answer is C. Power stroke equals sine ignition drives piston. Read the question and select your answer. The correct answer is C. Vaporizing breaks bonds completely. That completes video 17, and with it, the thermodynamics topic. Next time, we move into optics, starting with reflection and refraction. See you there.